Hi, hello. Now we are going to discuss a new topic about Thevenin's theorem in circuit analysis. Suppose we have a network or circuit that contains a lot of resistances, current sources, voltage sources. Then that will be little bit difficult to find the solution for a particular situation using a conventional method. In that cases, the entire network can be reduced or into a single resistance and is a single voltage source. Means a circuit. Suppose we have a circuit containing current sources, voltage sources, and many resistors. We can convert that big circuit into a single circuit containing a voltage source, so that is known as Thevenin's voltage source, and a single resistance RTH known as the Thevenin resistance that should be connected in series with the Thevenin voltage. This theorem is known as Thevenin's theorem. Okay, statement is given here. States that any two-terminal network having a number of voltage sources, current sources, and resistance can be replaced by a simple circuit consisting of a single voltage source VTH known as Thevenin voltage and the resistance RTH known as Thevenin resistance. That should be in series. Okay, that means we have a circuit containing how many voltage sources here? V1, V2, two voltage sources, and five resistances. Five resistances are here, and also one current source is there. Okay, this circuit is comparatively a bigger circuit consisting of five resistors, two voltage sources, and a single current source. This entire network can be replaced. That is what the Thevenin theorem says. Can be replaced by a single circuit containing voltage source and a resistance only. Means this entire circuit can be replaced using a single voltage source, that is known as VTH or Thevenin equivalent voltage source, VTH, and a series resistor that is known as Thevenin equivalent resistance. Means this entire network can be replaced using a single resistance and a single voltage source. Okay, let us refresh the Thevenin's theorem once again. Suppose we have a lot of voltage sources V1, V2, etc., and current sources I1, I2, I3, etc., and so many resistances, and circuit is a larger circuit, is a bigger circuit. Then we can convert this entire circuit into a single voltage source and a single resistance. That is the explanation for Thevenin's theorem. Okay. Next, how can we find the Thevenin voltage source VTH? That is given in the next paragraph. Okay. The value of voltage source is the open circuit voltage across the terminals. Across the terminals in the sense about which points we are going to suppose here A and B. Now we are going to find the Thevenin equivalent across A and B. Then that is the meaning of two terminals of the network. Okay, value of voltage source is equal to the open circuit voltage across the two terminals. Means suppose we have to find the Thevenin equivalent circuit of this one, means across A and B, then VTH is equal to the open circuit voltage across AB. In this case, VTH will be equal to V across A and B, VAB. Okay, right. That should be open circuit voltage. And how can we find out the value of RTH? That is also given here. Resistance is equal to the equivalent resistance measured between the terminals. Means the RTH will be R across A and B. Equivalent resistance across A and B. Equivalent resistance feeling across A and B, that is RTH. And VTH is the open circuit voltage across that. Okay. Okay. Now let us go through an example for Thevenin's theorem. A circuit is given and we have to find the current passing through 24 ohm resistance using Thevenin's theorem. That is the question. We have a single voltage source and three resistances here. We have to find out the current flowing through the 20 ohm resistance, means the current flowing through this branch. That is what we are going to find. In this circuit we can apply by applying the current division rule also, but it is specified here that to solve the problem using Thevenin's theorem. Okay, right? For that purpose I'm going to redraw the circuit again. Okay, solution or answer. Okay, this is our circuit given. We have to find the current flowing through 20 ohm resistance. So first step using the Thevenin's theorem is just mark the points, mark those points A and B. And we have to find the current through 24 ohm. So we have to remove 24 ohm resistance from the circuit. That is our first step. Okay, this is our first step in which we have to remove or disconnect the circuit resistance 24. Okay, 24 ohm resistance is disconnected from the given network and it is drawn here. That is our first step. Then find the voltage across A and B, means we have to find the voltage across A and B. Now this is open circuited and now we are going to find the open circuit voltage across A and B. That means going to find VAB. That will be of course our Thevenin voltage VTH. VAB should be VTH as Thevenin voltage source. VTH is the open circuit voltage across the two terminals. So of course VAB will be VTH. Now how can we find VAB? We can by any means we can find the voltage across here, but that will be very simple, or most easiest way is use a current division, sorry, voltage division rule. By voltage division rule we can simply evaluate the voltage across A and B. Okay, right? And the concept of a voltage division rule is explained in my previous video, and that will be, and the link will be available here, and the link will also be available in the description box shown. Okay, now let us find the VAB or V voltage across A and B using current voltage division rule. By voltage division rule, voltage across AB is equal to voltage across the 12 ohm resistance. Okay, then by voltage division rule, voltage will be distributed, total voltage into about which resistance we are going to find the drop, 12 volt, sorry, 12 ohm. So 12 divided by total resistance in this loop. Total resistance in the sense 2 plus 12. 2 plus 12. That will be the voltage drop across 12 ohm resistance. That will be VAB. That will be V12 ohm will be equal to VAB. VAB should be equal to VTH. 12 divided by 14, that will be equal to 8.57. okay, right? And now one thing is over. We got V12 ohm, that is VAB, that is equal to VTH. VTH is equal to 8.57 volt. Just to mark it as equation 1, as we have to draw the Thevenin equivalent circuit for this network. Okay, right? Next step is from this figure we have to evaluate the Thevenin equivalent resistance RTH. Okay, VTH and RTH should be there. Thevenin equivalent voltage source should be there, and Thevenin equivalent resistance should be there in order to draw the Thevenin circuit. Then we can convert this entire circuit into a single voltage source and a single current source. Okay, right? Now let us move to the step 2. Now this is our second step. Find the resistance across AB. Find the resistance across AB. That is RAB. We have to find RAB. That will be equal to our Thevenin equivalent resistance RTH. RTH. That is the second step. Find the resistance across AB. That is RAB. That should be our Thevenin equivalent resistance. How can we find the resistance across here? Here we have two resistances and a voltage source. That is not possible if we have a voltage source or current source is there. Then that is not possible to find the equivalent resistance. Suppose we have a voltage source is there, then we have to nullify its effect. Nullify in the sense we have to eliminate, but we can't remove it from there. If it is a voltage source, we have to short circuit it, means directly short circuit, then the voltage will become 0. Okay, right? In order to nullify a voltage source, we have to short circuit. Okay, short circuit means 0 voltage. And suppose suppose this is a current source, then left it open. Then you know that the current cannot flow through an open path. So in order to nullify the effect of a current source, we have to open it. Then in the open circuit, there will not be any current. Okay, right? Okay, in our case, we have a single voltage source is there. Then how can we nullify the voltage source? Just short circuit it. I'm going to redraw the circuit after short circuiting this voltage source. Okay, right? Okay, now I short circuited 10 voltage source, so its corresponding voltage is 0, so that I have not shown here, and the remaining 2 ohm resistance and 12 ohm resistance are connected in the circuit. Okay, now let us find the resistance equivalent resistance across RB. Means we have to find RAB. That will be equal to RTH. How can we find the resistance across A and B? If we look at this network, we can say that the leads of the resistances are connected together. Okay, both leads, both the left hand side and upper side are connected together, and the left hand side of the resistance 2 ohm and the bottom portion of 12 ohm resistance are connected together. So this circuit is simply a circuit look like this. This 2 ohm resistance and the 12 ohm resistance. Okay, both the circuits are same. Then what about the relationship between 2 ohm and 12 ohm? These 12 ohm and 2 ohm resistances are connected in parallel. They are parallel to each other. Okay, then we know the equation for the equivalent resistance for a parallel circuit. Okay, this is the equation to find the equivalent resistance across a parallel circuit. Suppose we have two resistances R1 and R2, and they are connected parallel to each other. Okay, right? Then we are going to find the equivalent resistance across A and B. Then the formula can be written as 1 by RAB, 1 by R across AB is equal to 1 by R1 plus 1 by R2. Suppose we have more resistance, let us add plus 1 by R3 plus 1 by R4, etc., etc. Okay, right? Now I'm going to write the right hand side. The LCM should be R1 into R2. Okay, then R2 plus R1 if we multiply, cross multiply. Okay, right? Then equivalent resistance RAB. How can we find out RAB from here? Just taking the inverse. Here it is 1 by AB. So again invert it. Means invert both LHS and RHS. Then we are getting R1 and R1 R2 into R1 plus R2. Okay, that is the equation for finding the equivalent resistance in a parallel circuit. Okay. In our case, these resistance 2 ohm and 12 ohm are parallel to each other. So, how can we find out the corresponding resistance across A and B? RAB will be equal to, by formula, we know that RAB is equal to R1 R2 divided by R1 plus R2. Okay, right? So, in place of R1, we have 2. R1 into R2. For R2, we have 12 ohm divided by R1 plus R2 in the sense 2 plus 12. 2 plus 12, that is equal to 2 into 12 divided by 14, and we are getting this one as 1.71 ohm. Okay, that will be of course our Thevenin equivalent resistance. Okay, now we go to the equivalent resistance across AB, that is equal to 1.71 ohm, and let us mark it as equation number 1. From equation number 1, equation number 2, from equation number 1 and 2 we have VAB is equal to VTH is equal to, what was that? That is equal to 8.57 volt by equation 1. Now we can replace the entire network in step 1, means this circuit in the step 1. Please note the circuit in the step 1. Before that we have an additional resistance of 24 ohm. We removed it, disconnected it, because it's given to find the current passing through that network. So we disconnected it from the circuit. Then we got the circuit. Okay, now we are going to replace this circuit using Thevenin circuit. Okay, that is our next step. Step 3, replace the circuit in step 1. This is the circuit in step 1. Now replace this circuit using corresponding its Thevenin equivalent circuit. What is Thevenin equivalent circuit? Thevenin equivalent circuit will be the voltage source VTH and a series resistance RTH. Then this Thevenin equivalent circuit across AB. Thevenin equivalent circuit across AB will look like this: VTH followed by a series resistance. The magnitude of VTH we obtained is VAB, that is equal to 8.57 volt. And what about this one? RTH we obtained is 1.71 ohm. Okay, and that is the equivalent circuit for this circuit in step 1. Okay, now we are about to finish the topic. Let us move to next step, and that will be the final step, step 4. The next step we have to connect the 24 ohm resistance back to the network. Okay, here we disconnected it from A and B. Now we found the Thevenin equivalent circuit for this one. Okay, we obtained the circuit as this one, and finally we have to connect back the disconnected resistance across A and B itself. Now we can connect across here. VTH is 8.57 and RTH is 1.71. A and B, here we can connect a 24 ohm resistance. Now let us back to our problem. In the problem, the question find the current passing through 24 ohm resistance. 24 ohm resistance in the sense the current in this loop. Okay, how can we find that? Simply speaking, current is equal to voltage potential difference by total resistance. Okay, right. Then current I is equal to potential difference is 8.57 volt divided by what is the total resistance. Total resistance, two resistances are there. First resistance 1.71 plus 12 ohm resistance. That will be 0.33 ampere. Okay. Now it's over. Thank you.